Hi, this is an IV chemistry video that focuses on the topic of atomic structure, and I'll only be discussing the SL portion because as I said in my previous videos, I take SL chemistry. So today I'm going to be I'm going to be discussing atomic structure, and please just try to ignore this message at the bottom which says that it's a free trial. I don't know what, it's really annoying, but just ignore it. The first, most basic thing you need to know, I'm going to go over this really quickly, by the way, because you should already have an understanding of what atomic structure is, and you should be using this video kind of as a revision for the exams that are coming up in only a few months. Okay, so the most basic thing that you need to know is how to calculate mass number and atomic number, okay, of any elements given on the periodic table. The mass number is equal to the number of protons and the number of neutrons of that atom, or of the element. And the atomic number is the number of protons and the or this is the key word, or the number of electrons. Okay, in any element, if it's a neutral element, the number of protons is equal to the number of electrons. That's why it says or, because it doesn't make a difference. However, if it's an ion, for example, in the case of carbon 2 plus, which has negative 2 electrons, okay, basically the number of electrons is 2 less than the number of protons, okay? And this is how you would calculate the number of electrons in a carbon or any element, okay? This is how I remember it. Mass number, which is denoted by A, it's always the bigger number in the periodic table, and the atomic number is always a smaller number. And you just have to try to remember it because it can get really confusing, and you can just lose really easy points by getting them confused. So the number of protons in any element always remains constant no matter what. Okay. However, the number of electrons change. That's why you get ions, and the number of neutrons can change as well, and that's how you get isotopes. Okay. And isotopes have different mass numbers clearly because they have different number of neutrons, which would give you different mass numbers. Okay. So the definition of relative atomic mass is, you get this question really often. They always ask you to define these kind of terms. You'd have to be able to define it. It's the average mass of the isotopes of an element. Okay? And the way to work it out is, I've given the example of chlorine, which has 75%, in a sample of chlorine, if you're given a sample of chlorine, you'd have 75% of chlorine 35 and 25% of chlorine 37. And the way to work out the relative atomic mass is by multiplying the percent and the mass number and adding them together. So 75 times 35 plus 25 times 37 divided by 100, and you get 35.5 as the relative atomic mass, and this is the number that's actually given to you on the periodic table. Okay? The next thing you need to know is how do we calculate how do we know that in a sample there's 75% of 35 chlorine and there's 25% of 37 chlorine? Well, basically, we use a mass spectrometer to calculate this, okay? And what it does is it measures it. Okay, we'll go through the steps, okay? But what it does basically is it figures out how much, okay, of chlorine, for example, how much of each isotope of that element is present, okay? So, from that you can calculate the relative mass number, okay, relative atomic mass. So the mass spectrometer, there are 5 steps, and you need to learn them by heart because you get this question often, okay? The first step is to vaporize a sample of that element, okay? The second step is to ionize the atoms of the element by bombarding them with electrons. The third step is to accelerate the atoms using an electric field, okay? The fourth step is to deflect the atoms, the ions, okay? And you'll get this question often, which is, what factors affect the level of deflection? okay, of an ion. Basically, you have to say the factors are the mass of the ion and its charge, and something else that sometimes they ask you for three factors. You can also include the speed the ion is going at. Obviously, if it's going at a higher speed, it's going to deflect more than if it's going at a slower pace. Okay, the last step is detection, okay, which is the mass spectrometer. What it does is it measures the mass of the ion and the relative amount of the ion that's present in the sample. So in the case of chlorine, the mass spectrometer calculated that 75%, which is the relative amount, is present of 35 chlorine, is yeah, which is the mass of the ion. And from that you can calculate the relative atomic mass. Okay, you can remember the steps using the acronym that I love. I think it's kind of cool, which is HIV is a deadly disease. So vaporization, ionization, acceleration, deflection, and detection. Another thing you need to know, and you might be asked about, is what are the uses of radioactive isotopes? We just have to learn them, okay? So for carbon-14, it's used for carbon dating. For CO60, it's used for radiotherapy. For iodine-131 and iodine-125, they are used as medical tracers for the treatment and diagnosis of diseases and illnesses, okay? Then moving on to the electromagnetic spectrum. As you go across the electromagnetic spectrum this way, yeah, um, the energy is higher and the frequency is higher of the actual wave. Okay, so the wave with the least amount of energy is radio waves, then microwaves is higher, then infrared is higher, visible light has higher energy, ultraviolet, then X-rays, then gamma rays. Okay, and you just have to learn this. It's really important. You might be asked which one has a higher energy. Okay, so learn it. Okay, the next thing that we're going to talk about is the atomic emission spectrum. Basically, we know that light, if we shine light through a prism, it'll give us a continuous spectrum, which is like it's like a rainbow. It gives you all the lights, all the different wavelengths. Okay. However, if you shine light, okay, into an element or an atom, okay, you're going to get an aligned spectrum, okay, which only includes emissions at particular wavelengths. It doesn't have the whole entire. Basically, you can think of it as it won't have the whole entire rainbow. It'll just have a few of the wavelengths, okay, and basically, what happens is when you how do we get these wavelengths? Okay, because this is what a line spectrum kind of looks like. Okay, it's kind of like that. Okay, and each one of these lines, okay, is a wavelength. Okay, okay, my horrible drawing. I'm so sorry. Basically, you get when energy is absorbed by an electron in an atom, it gets excited and it jumps to a higher wavelength. Okay, we don't know which wavelength exactly. It can be up to infinity. We just say infinity. Okay, however, eventually the electron loses its energy and it drops, and when it drops it emits energy that gives off a particular wavelength. Okay, so if the electron drops to level 1, okay, which is the lowest level, okay, it gives off ultraviolet light, okay, and this is the largest drop, okay, because it can only drop from infinity to 1, obviously, okay, that's the largest drop. Then if it drops to level 2, okay, then it emits visible light. If it drops to level 3, it emits infrared light, and you just have to learn these, okay? These are facts that you need to know, okay? So, and remember that these electrons always drop to their original, what's it called? Energy level. So if you have a hydrogen atom, for example, okay, if energy is absorbed by the electron, it jumps to a different wavelength. We don't know which one, and so we're going to call it infinity. Okay, then eventually it loses that energy and it drops back to its original wavelength. It drops back to its original what's it called? Energy level. Yeah. And when it drops, it gives off a particular wavelength. The thing is, it's not going to drop to any random energy level. It's always going to drop to the first energy level because that's its original one. Okay? And because it drops to n equals 1, it always gives off ultraviolet. Okay? And sometimes you're asked this question. Okay? Uh, in an in a in a what's it called? In an emission spectrum, okay, which kind of looks like this. The reason that the lines converge, sometimes they'll ask you, they converge, they get closer at the top, is because the energy levels of an atom always converge as well. As you move across an atom, they converge as well. Okay, so just learn that. Okay, ionization energies. That's another thing you need to know. And basically, it's defined as the energy required to remove an electron from an atom in its gaseous state. If you don't want to learn that definition, I prefer you just write this down and learn it, okay? But don't forget the state symbols because that's important. You always have to mention that that it's in a gaseous state. If it asks you for the first ionization energy, this is the formula you give. If they ask you for the second ionization energy, you always take this one from the first, the product of the first, put it here, and then you take off an electron. Okay, it's just really easy. Okay, so sometimes they'll ask you to give evidence of energy levels. How do we know that there are energy levels in an atom? Okay, basically what you can say is that as you go down a group, okay, the ionization energy decreases because of the presence of energy levels. Down a group, you'll have more energy levels, and the first ionization energy to remove the first electron, okay, which is the farthest away in the valence electron, it's the hardest because it's the easiest, I mean. Okay, let me explain this in a better way. Basically, if you have, if your valence electron is far away, okay, because there are many energy levels, okay. For example, in chlorine, yeah, chlorine has 3 valence shells, okay. Its valence electron is really easy to remove because it's so far away from the neutrons and it's not held tightly together. It's really easy to remove. So the ionization energy is not high. However, for example, fluorine, okay, which only has 2 valence electrons, it's easier to remove the valence electron because it's closer, okay, it's closer to the nucleus, and so there's greater electrostatic attraction and it's held closer together, so it's harder to remove. So as you go down a group, ionization energy decreases. Okay? However, across a group, ionization energy increases because there are more neutrons and more electrons, which means that there's greater electrostatic attraction, which means that the new electrons are held closer together to the nucleus, and it's harder to remove the electrons. So the ionization energy increases across a group. Okay, so I hope this video has helped you, and I hope you're more prepared to tackle atomic structure questions for IB. And I'll be updating a video that actually deals with IB questions for the atomic structure. So stay tuned for that.